Hello everyone, welcome to the afternoon stream. My name is Dude Zord and I do cool game dev stuff here on Twitch. And today I'm working on my own Game Boy emulator written in Rust. I guess today is day number, let me see if I can even tell you this. Today is day number 22 of the Game Boy development. We are able to play a ton of games so far. But currently we are trying to make Game Boy Pokemon Red work. Why doesn't it work? That's a great question that I don't know the answer to. Yeah, I'm essentially trying to figure out as we go. So let me quickly change the scene here. So I can quickly show you. Am I running the wrong stuff? I am. I can quickly show you that we can get the game to boot. We see the start menu. We can click start. It starts all of the interaction with Professor Oak. But then for some reason that I don't know why, it just doesn't continue after that. I have a slight suspicion of what that issue can be. Can I magnifier? Off we go. There he is. You can see Game Freak. We see a Nidoqueen with a Ghastly battling it out. Pokemon, really cool red version. Yeah, so all of these parts here apparently works fine, but once we start the new game, Professor Oak comes into the screen and then nothing happens. And I don't know why it doesn't work. I have an idea of why it doesn't. So that's what we are gonna explore today. So the Pokemon Red ROM, the cartridge itself, is one of the largest games that released for the Game Boy. And in reality, if I can show you this somehow, this game is 1 megabyte game, while, for example, Tetris is only 32 kilobytes. Okay, and one of the things that the Game Boy needs to do, or like these very large games, is essentially needs to map different addresses of memory whenever you write some index to a specific register, which means that although you might be reading and writing always on these, between this address range, for example, between 4000 and 8000 hexadecimal, in reality, the values that you will be reading will highly depend on the ROM bank that is currently selected. And apparently, according to the Game Boy, there are a ton of different ways where we can index these different ROM banks. Each ROM bank is only 32 kilobytes in size, or is it 8? No, I think it's only 8 kilobytes in size. So as you can see, there are like plenty of opportunities here to explore how to address these different regions of memory. It seems like Pokemon Red uses, or the cartridge references that the type of memory banking that it's going to use is the type 13. And we can actually go and check the cartridge header, and if we navigate to the cartridge type, which is this, you're gonna see that the number 13 means we are using the memory banking type 3, MBC3, and then it also has an external RAM for saving the game and the battery to make sure that the save game doesn't get lost, you know. Currently, we only have support for ROM only, which is the 32 kilobyte games. We added support for MBC1, which is, for example, what Super Mario Land uses. But yeah, technically, we should be able to implement all of the different memory banking protocols. Currently, we either have none or support MBC1, and now we are going to need to support MBC3 for this game. We might end up implementing more of them today, But I would say that as long as the Pokemon Red works, I think we pretty much have everything we need here. So let's see what we need to figure out in terms of MBC3. So as you can see, whenever you don't have whenever you don't have a memory bank chip, then the games are only 32 kilobytes, which means that you can essentially map the entire game between these address from 0000 to 8000, which is 32 kilobytes. But then there are other games that also have RAM. And this RAM can be connected or can be accessed through A0 to BFFF. Now, what type of game would be a no MBC with RAM? I have no idea of an actual example, but yeah, I don't know what game could that be. But yeah, that's a no MBC. That's what it stands for. Essentially, all the 32 kilobytes are mapped to this 32 kilobyte memory range, which is pretty much simple. It's just you read and write directly. You don't need to care about like switching in and out the different addresses. It just works like magic, you know. Then we have memory bank chip 1, which, as far as I remember, this is what we currently have in place. But this is very hard-coded, you know. This is very hard-coded on the code that we have here. So when reading from the memory map, essentially, if we are reading before 3Fs, we are referencing ROM bank X0. Or if we are reading between 4000 and 7Fs, which is this part here, we are reading from the bank that has been indexed by something. But this is kind of weird. Well, it's not kind of weird. It's like it's very hard coded to this specific memory bank situation here. So I wonder, how can we actually extend this in a way that we will be able to support different memory banking chip protocols. This is for reading, and then for writing, you will see that, for example, for MBC1, this is like all of the code to MBC1, you know, where it tells you which bank is used for the ROM, which bank is used for the RAM, what type of banking mode are you using. I don't recall what this means. So yeah, I think we kind of need to generalize this in a way where at boot time we can infer or defer the MBC protocol that we're going to use, and we essentially create like a dynamic object that handles all of this for us. That's the plan, at least. That's the plan. So how could we do this properly? Maybe let's read again what MBC1 is supposed to be doing, you know, and yeah, let's maybe check first what this is supposed to be doing, and then we will figure out something. Okay, this is the first MBC chip for the Game Boy, and newer MBC chips work similarly. It's relatively easy to upgrade. Okay. So, in its default configuration, MBC1 supports up to 512 kilobyte ROMs, with up to 32 kilobytes of banked RAM. Okay.
Some cartridges wired MBC differently. Nothing that matters. Note that the memory in range 0 to 7Fs is used both for reading from the ROM and writing to the MBC control registers, which is kind of what we have here, you know. Whenever we are writing values on that range, depending on the region where we are writing to, something different happens. Okay, so in this case, this is read-only. So if we are reading from the memory between 0 and 3Fs, which is essentially this, this contains the first 16 kilobytes of the cartridge ROM, which is this. But then it also says that in 1 megabyte and larger cartridges, entering mode 1, which is something that we are doing somewhere, I think it is banking mode. Entering mode 1 will allow that second banking register to apply to reads from this region, in addition to the regular 4,000 to 8,000 banked region. Holy is this. Holy is this difficult to understand. Okay, but by default this is bank 0. But then it can also give you access to banks 2014-60 if the size of the ROM is larger than 1 megabyte, which I guess we have like that. We should have like something there to protect us from. Okay, and then between 4000 and 7Fs, this contains another 16 kilobytes of ROM. So the banking register, it's always minimum 1. So even if it's set to 0, it should be set to 1. So this ROM bank here. Okay. So let's try to figure out what more can we do here. For more than one megabyte ROMs, this means that any bank that is possible to access via the 0 to 4000 region is not accessible in this region. Maps to one bank higher. Yeah, well, I don't care for larger than 1 megabyte ROMs for now. I think. Maybe the Pokemon one will use that, but I don't think it will. Then we have the A0 to BF, which is RAM, which I don't think we have any specific guard in there as of now, that is. But apparently we can manipulate the ROM bank somehow, and then whenever we try to write here, we are actually writing to like a different part of RAM. Okay, let me think. Okay, because I would assume that the RAM wouldn't be part of the memory map, you know? Like this would be the... So I have the game ROM, then I have the memory mapped stuff. So if the RAM is not enabled, reading from these should get me FFs. And writing to these should be ignored. Okay. Okay, so I might as well better like implement the rest of this stuff here, you know, and then we'll see how easily can we generalize this. Memory map. Okay, so if the RAM is not enabled, writing there shouldn't do anything. Else it should do something. Yeah, but this is the part that is like difficult to understand, you know, because I should be able to get the RAM bank from here. This should give me like an index, you know, RAM bank 1. Well, apparently RAM bank starts at 0. Okay, so it kind of seems to me that this memory map, this is like ROM data, always, you know. How much is 10,000 in hexadecimal? $65K. No, because hold on. Right, so I have the data. The thing is that for some of these addresses, this won't matter, but this just means that at the maximum only 65 kilobytes are mapped. But I don't actually use all of this data, you know? Because for specific intervals of addresses, I go literally directly to the game ROM. So I kind of feel that I might as well have like some RAM in here. You know? Okay, how much RAM can I actually have in one game? What is like the maximum? 8 megabytes. No, RAM. Okay, ROM can be this, but RAM can only be 128. 128,000. Which is this? It's 20,000 hexadecimal. Okay, so this is like the maximum RAM that I can have. Okay. Yeah, and the ROM doesn't really matter because the ROM is just gonna be indexed, so it's whatever. So this is whatever. Okay, but let's assume then that our RAM is gonna be that. So we have 256 kilobytes of zeros in there. Okay. And whenever we read from it, so each bank is 8 kilobytes in this specific case. Available RAM sizes are 8 kilobytes in form of 4 8K banks. 32 kilobytes is only available in cartridges with ROM less than 512. External RAM is often battery backed, allowing for the storage of game data. Okay, it's fine. In any case, this RAM bank, it will give me like an index from 0 to 4 or 0 to 3, and I'm gonna multiply these by 8,000 seemingly, OX 2000. This is gonna be the index. This is gonna be the base index for my RAM. You know, this is writing. Okay, and then the index that I have to subtract this. Yes. And then I do memory map .ram RAM base index plus offset equals value. Then I return. Okay. This is for writing. And then for reading, should kind of be the same. For reading should be the same, although by default I'll just return OXFF, This is gonna be the index, and then here I'm gonna return this. Okay, so this is the RAM banking part. Okay, and then we have the registers. Okay, so writing to 0 to 1Fs, which is this. Before external RAM can be read or written, it must be enabled by writing OXA to anywhere in this address space. Any value with A in the lower 4 bits enables the RAM attached to the MBC, and then any other value disables it. Okay, so the RAM enable part is done. Then we have the ROM bank number, which is 2000 to 4000. Okay, and this will tell us which is the ROM bank to map to this interval here. Okay, and selecting the writing as 0 is the same as writing as 1. And here I'm just reading like the ROM size just so it behaves kind of properly. Although it shouldn't be like my responsibility. No, I do need this because this can like loop around, right? I think. If the ROM bank number is set to higher value than the number of banks in the cart, the bank number is masked to the required number of bits. Oh. If the ROM bank number is set to a higher value than the number of banks in the cart, the bank number is masked to the required number of bits. Hmm. .256 kilobyte card only needs a 4-bit bank number to address all of its 16 addresses. Banks. So this register is masked to 4 bits. Oh. So depending on the number of bits, Okay, I'm confused. I am confused. So I kind of need to know. I mean, the number of... I think these are never seen, right? Okay. Yeah, so these are always a multiple of 2. So I can subtract 1. Oh, which is what I'm doing here. I can subtract 1. This gives me the number of... no. No, see, it's the ROM size divided by 16, right? That's the number of total ROM banks that I have. By 16. So it cannot be... This needs to be a 4000. Okay. So it's the ROM size divided by 16 gives me the number of banks. But I can also do... Hold on. So confused. ...256 kilobytes, 16 banks. So this register is masked to 4 bits. Okay, so in this case this would give me 15. So this shouldn't mean... I don't understand this. But I think this logic is wrong, because what this means is that I should hand this number you know. Goodbye. The wrong bank number is set to higher. The bank number is masked. Okay, I think what I need to do is this, and then I need to say and this, you know. I think this is what that means. The upper bit would be ignored for bank selection, yeah. Even with smaller ROMs that use less than 5 bits for bank selection, the full 5-bit register is still compared for the bank 0 to 1 translation logic. As a result, if the ROM is 256 kilobytes or smaller, it is possible to map bank 0 by setting the 5th bit to 1. It will prevent the 0 to 1 translation. On larger cards which need more than 5 bits bank numbers, but I mean five-bit numbers, it means that how do I do a power? Do I have like a programmer calculator here? Not really. Okay, so it's 2 bits, 3 bits, 4 bits, 5 bits. No. It's 32. But then it's 32 times 16k, which is 512 ROM. On larger cards, which need a more than 5-bit bank number, the secondary banking register at 4,000 to 5 is used to supply an additional 2 bits. Okay. Which I guess is this part here. Okay, so this can either be used for RAM bank number, which is what it's doing, or to specify the upper 2 bits of the ROM bank number. But this is only if the card is larger than 1 megabyte. If neither ROM nor RAM is large enough, setting this register does nothing. Hmm. 10,000. Well, I do have this here. So might as well do that there. Okay, so whatever I do here will depend on the size of the ROM. So if the ROM is larger than 1 megabyte, then something happens there. Oops. Okay, so here I get the bank number, but I set this bank number there. But for the ROM bank, it's going to be different, won't it? It's going to be it's going to be memory map.rom bank. It's going to be bank number shifted 5 or with memory map.rom bank. I think. Something like this, right? Okay, because if this is larger than 1 megabyte, I only want to set the lower 5 bits. I think here I want to do ROM bank equals that, and here gonna be ROM bank how do I set this? So it's going to be these values, but something like this, right? Like the top 2 bits, and then I just replace the other 5. Yeah, I think this is it. Then the banking mode, whatever this means. Do I even use this banking mode for anything whatsoever? No. This 1-bit register selects between the 2 controller modes. Controlling the behavior of the secondary 2-bit banking register above. Oh. If the card is not large enough to use the 2-bit register, this mode has no observable effect. The program may freely switch between the 2 modes at any time. Okay, so if the banking mode is 0, 0 through 3Fs and A0s through BFs. So this and this are locked to the bank 0 of ROM. Bank 0, bank 0. Can we bank switch via the 4005F? The hell? Confused already. Confused already. Are locked to bank 0. Okay, so if banking mode is 0, then those are bank 0. The hell? Something like this, right? Okay, where do I use the ROM bank? Well, it's not for writing, it's only for reading. Which is this part right here. So if the banking mode is 0, then my ROM bank will be actually 0. And this will give me a -1. This is a use size. And this would crash. I think this works. Okay, addressing diagrams. So zero 3Fs. Hold on, what are these numbers? Are these bits? No. Okay, confused. Yeah, I don't know what that means. Okay, let's assume that this is working now. Okay, so this is memory bank 2, memory bank controller 2. Read only. Okay, this is the Gameboy index, but here it supports up to 16 ROM banks. But then here you will have like RAM. The MBC doesn't support external RAM, instead it includes 512 half bytes of RAM built into the MBC2 chip itself. It still requires an external battery to save data during power off though, as data consists of 4-bit values. Only the lower 4 bits of the bytes in this memory area are used. I feel like I kind of want to expand this part here when reading to like the memory bank controller. You know? What does MBC3 do? Yeah, but MBC3 doesn't have the banking mode. Fuck. Okay. Okay, it feels like I'm gonna need to create different MBCs. You know. Okay, let's see how can I do this. So here I'm gonna have a banking mode. Right, MBC1 will have a banking mode. You're gonna have a RAM bank number and the ROM bank number. And then here on the trait, I'm gonna need to have like a read and a write or something. Is it always these addresses? 0 A1F or BFF 0. It's freaking weird, bro. It's freaking weird. Mm, 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 mm. Okay, let me see. What do I need here? ROM bank and RAM enabled. In banking mode, use size. Okay, I actually think that this should get me the... Instead of like manipulating the data, this should just get me like the actual address that I need to calculate, you know? Um, well, here I can just call like an option. Use size. Something like this. So whenever I get something on this range, I'll call either read or write, and they will return me like the address in which to actually do something. I think. Okay, so what do I need to do here? I'll create an MBC, and this needs to be a type option, and it's going to be a boxed MBC needs to be send plus static. Well, I don't know if I cannot add derives there. Right. But why does it need to be static? It needs to be this. Oh well. This is the part of Rust that I enjoyed the most. Nah. Absolutely not. Okay, so how do I do this? PubFN initialize MBC. I'm gonna need to do this and then memory map dot MBC equals some box new, and then it's like MBC1, something like this. Okay, this is my plan. I mean, I'm gonna have one called no MBC. Impl MBC for no MBC. Okay, so on no MBC, I mean, it should be easy. Like the address that I get in is the address that I like return. So now let me see what I need to do here. Banking mode, RAM. So it's like all of these. I mean, the boot finished, I would say it's part of the memory map. Yeah. If let some MBC equals this, gonna be MBC dot if let some address equals MBC dot right the size. I mean, I'll probably need to pass a value. No, index value. Then I do memory map dot. Yeah, well, writing is always writing to RAM. So it needs to be this. Something like this. This is my plan. This is my plan. Yeah, so my plan is to do something like this, where I ping the memory bank controller, I try to write a value there to like update internal state somehow, and if it returns me an address, then that is like the address in RAM that I need to do stuff from, you know. And I'll kinda need to do the same thing here. Something like this, and then I don't really want to copy the value, but here this gets me an address, and then if this address is below something, I wonder. No, I don't know, but here I need to somehow differentiate if this read is from a RAM or ROM, you know. Maybe I can do this read ROM. Read ROM index goes this, and then here I should say read RAM, and I say memory map dot RAM address. So first I check if this belongs to ROM. If it does, I read from ROM. Then I check if this belongs to RAM. If it does, I reads from RAM. Do I like this? I'm not sure if I like this, to be completely honest with you, but that's what we have. That's what we have. Yeah, so this is my plan to like do this. I return like the offset in ROM that I need to read. You know, if you know, you know. So this party is from there. Okay, and here I return this. Should I pass the memory map to inside the memory bank controller? Okay, so maybe these should be the sizes. Not exactly sure how to handle like this part here, you know? I wonder if these, instead of being an option use size, if this should be like an enum. And then the enum could either be like a no op, like a no, I'm not on this boundary, or return an hard-coded OXFF, or return an offset, you know. Something like that, and then I do a then it either can be a nothing or an address or a value, you know. Something like this. And here I'll do a value that and here will be an address. Yeah, maybe I like this. I don't know. Yeah. Well, I could call it read, and then I could either get a ROM address or a RAM address, you know? And then I could have all of, instead of calling these two, I could just call one read. Yeah, maybe that's what I want to do. And then it's RAM address or an address RAM, address ROM. You know, maybe this, I don't know. This address ROM, this address RAM. Yeah, maybe I like this, I don't know. Then I do match mbc.read index. And then if it's an address ROM, oops, ROM. If it's ROM, it's this. If it's RAM, it's this. And then if it's nothing, it's nothing. Do I like this? Oh, and this can also return me a value. You see. So if this returns me a value, I just return the value. Yeah. Okay, what more can I do here? I mean, I'm pretty sure the most difficult one is gonna be like having the MBC1 working with this, because then should be fairly easy to extend, hopefully. I mean, I probably don't care about this, you know? Or do I? I mean, this already has the game ROM there. I could like literally pass the game ROM as an argument. Yeah. Okay, this is gonna be an actual RAM of this. Um, okay. And then here I'm gonna match on this guy. Okay, nothing, there's nothing, returns a value. This doesn't should be unreachable. This should be unreachable. Writing on the ROM should be unreachable. Writing to RAM. Should be this. And nothing is nothing. Good job. Why do I have this here? FEA 0, not usable. Oh. Okay. Okay, so reading should always read something. Okay, obviously not doing anything because this MBC is set to none. Although I could probably start it as a no NBC, because then here it doesn't need to be an option. can just be a... No. Box new. Okay, yeah, whatever I've done is not working. Okay, so I probably need to go back to the memory map. Sorry, I was already on the memory map. I should probably try to open Tetris now. And I should get Tetris to work. Hopefully. Okay, it's crashing here. Okay, probably put this breakpoint. Okay, so it's crashing here. Why? Why? Address. OXFFF. Oh, but why did it reach here? Oh. Okay, never mind. Hold on. If address is less than this, then it's a nothing. Oh, return. I mean, and writing is the same thing. If A0s and less than BFFs, this, else, NBC result nothing, return. Okay. Okay, at least now we should be able to play Tetris, you know? Surely it's gonna work. Okay, I mean, it appears to be working. It appears to be working. Um, Kinda feels slow for some reason. Okay, but apparently this is working fine here. Because this cartridge uses no MBC because it's a type 0. So whenever we actually do the read cartridge whatever, which I guess we do here, I feel like I'll actually need to do like a initialize MBC. Or maybe I should do this dynamically, you know? Like we start with without a cartridge. Maybe that's the plan. Maybe we start without a cartridge and then I do CPU.load cartridge and I pass in a like a path. Like a path to this. I don't know. I kinda don't want to do it on the constructor though. Initialize MBC. I mean, can't I just call like initialize MBC directly here? Yeah. Yeah. Okay, so to initialize the MBC, I'm gonna need to grab the game ROM. Yeah, I need to grab the game ROM and then I'll need to like read some sort of data from there. Okay, let me see what I have. This type cartridge type gonna be this. So this is the cartridge type. And then a ROM size and RAM size as well. I mean, it's not really RAM size, like type, ROM size type, or enum or something. Something like this. But okay, let's see if we can actually like do this properly. Okay, so if cartridge type, I kind of like match on this, you know. Match cartridge type. BC equals this. No MBC. And implemented. Yeah, so my plan is to do something like this. I check the value for the cartridge, and then depending on the value for this enum, I will create like an object that holds the memory bank controller, and I attach that to the memory map, and then it should work flawlessly. Copium. Yeah. Okay, so impl no MBC new this. Okay, so this should work flawlessly for the current games that we have, which is Tetris. It should also work flawlessly to Voxel. But Super Mario Land, it's gonna be okay, pretty cool. Pretty cool. We don't support that. Okay, so if we now run this, we don't support cartridge type 01, which we actually do. Okay, which we actually do. So now I should be able to add an 01 entry here and pass an MBC1 new. I mean, I might as well pass ROM size, RAM size. Or RAM size code. And then I actually do. Yeah, I don't know if I should do this with codes or values. Probably this, but yeah, so here I can take a ROM size, which is going to be a U size, RAM size, which is going to be a U size, and I can store them. ROM size, U size, RAM size. I don't know if I'll need both of them. But eventually what I want to do is I don't want to pass in the game ROM to inside this like write method. I mean, it doesn't make much sense to me. For example here, if I don't pass the game ROM, then this is gonna complain a bunch. But I mean, I already have ROM size. You know, I already have all of this. So I can just do self.rom size, self.rom size, self.rom size. You know, pretty cool. Pretty cool. Which now means that whenever I actually instantiate this, I can have the RAM size code already. I have this. ROM size, RAM size. Okay, pretty cool. Oh. They actually need to pass like a DINA MBC. I need to do this directly, don't I? Fuck. I need to do this directly. Boxed. Well, might as well do this. Bloop. Okay. Okay, so now this means that we should be able to support Super Mario. Except not. Except it didn't work. Whoops. Except it didn't work. Unused though. Okay, what now? What now? Okay, I probably need to print the cartridge data. Oh, there's Simon's favorite music. Okay, so it's Super Mario Land. Well, it doesn't work. Why, you ask? Who knows? Who knows? Okay, so cartridge type is type 1, which is MBC1. ROM size. ROM size code is 1. So this means we have 64 kilobytes. Yes. And the RAM size should give 0. Okay. I mean, this part here is fine. So ROM size is 1. Okay, so bank number 3 and number of banks is gonna be 4. No, so this is number of banks and mask is gonna be this, and we mask with this. Okay, we need to figure out what the hell we messed up. Surely nothing too bad. Okay, is RAM enabled? No. Okay, so what does MBC1 say? If I'm trying to write. Oh no, this is a A0. This area is used to address external RAM in the cartridge. The RAM is only accessible if RAM is enabled, otherwise reads return open bus value, often FF but not guaranteed, and writes are ignored. Okay, so when do I actually set a RAM enabled equals to true then? Because it's trying to do a bunch of stuff there. Then it's calculating a bunch of stuff, but it's never enabling RAM. It's never enabling RAM. Very much confused. This is like trying to clear data there for some reason. Oh boy. Well, I know that one of the things that I did that I maybe shouldn't have done is this array RAM enable stuff when writing. Maybe it's not actually required, you know? Fuck. I also added these. Okay, there's something that I fucked up incredibly. There's something that I fucked up incredibly. And now I don't know what. And now I do not know what. I mean, this guy doesn't even have RAM, does it? No. Well, if this guy doesn't have RAM, like if RAM size is 0, I mean, but this is external RAM. And this RAM enable is only for external RAM. I mean, you need some RAM at some point, you know. Oh, but you have the work RAM. Eight kilobytes from cartridge. Well, if the cartridge type does not include RAM in the name, this should be set to 0. Okay, I'm confused. I'm 100% confused. Okay, there's been something that I've done with all of these moving code over that made this not work. I mean, here it should be literally this, and O2 should be RAM size. Ay, ay, ay. Why is it blinking? Why is it blinking? Because it's like trying to loop several times. This area normally contains the first 16 kilobytes of the cartridge ROM. Usually. Normally. So I would say that I'll probably need to move these over as well. My MBC is that, and this is a ROM address. Entering mode 1 will allow that second banking register to apply to reads from this region, in addition to the regular 4000 to 7F's banked region, resulting in accessing banks 20, 40, and 60 for regular large ROM cards. Yeah, but that's for 1 megabyte and larger, which we do not care about. I can probably do a if self dot ROM size larger than how much is 1 megabyte? 100,000. Yeah, but this is not the issue. So less than 3Fs, it should return me the ROM. Maybe the eyesight stuff is messed up. Does the RMA contain any of the further 16 kilobytes banks of the ROM? If the main 5-bit register is 0, it reads the bank as if it was set to 1. Okay. A0 to BF's RAM bank. Well, I don't have RAM, so I shouldn't enter here. Right? This is external RAM. So I shouldn't enter there. Ever. Okay, I don't enter here. Okay, so I'm never actually reading or trying to read the RAM from there. The RAM is only accessible if the RAM is enabled. Otherwise, reads this. Okay. Okay, and writing. So it's between 0 and 1 Fs, RAM enable. 0 to 1 Fs. I mean, the weird part is that if this is the address, and this address actually belongs to the ROM, I don't know. Because it's trying to write data here, you know? It's trying to write data at this address. For some reason. 057, 057. Not exactly sure why. Like, this shouldn't be doing anything. 1 FCB. Yeah, I mean, this address is, you're not supposed to write here. You're not supposed to write here. So I'm actually jumping there because I'm getting like short jump instructions. OX38. It's weird. It is weird. I really can't remember what the hell I did that messed this up, you know? Which is sad. Ay, ay, ay. Okay, I know I made some changes here. $2,000 to 3Fs. And this selects the wrong bank number. So maybe I'm doing something wrong there. Which would be fine. Bank number 3. I have 4. Wrong bank 3. Okay, and then wrong bank was 1, and I set it to 3. Okay. It's weird, why am I passing a number here? Oh, this number just gets me the wrong bank. I see. Bank number 25. Holy. $25 is 16, 8 and the 1. So it's only 1, yeah. If this register is set to 0, it behaves as if it's set to 1. Bank number 0. What have I done wrong? So this is calling back the same address a bunch of times. As if it was like clearing memory or something. It's weird. ROM bank number or upper bits of ROM bank number. I really don't know what I've messed up, but I messed up something. I have messed up something that I shouldn't. Yeah. How am I gonna find out what have I messed up? Okay, I need to diff this code again, I guess. I don't really see what could have been the reason. I mean, I started up with a RAM bank 1 and banking mode 0. I doubt this will make any difference. Okay, no difference at all. Okay, so write memory map. Write memory map. Yeah, I don't know. In this FF50, okay, this one is normal. Because the thing is that when I do this to enable the RAM, I shouldn't be writing there. And it kinda makes me feel like I am. Like this should be returning here. And it isn't, you know? I mean, this won't affect anything because this is just like a random piece of data. Oh. I never use this memory map like outside of this directly, do I? I better not. Read, write. Yeah, like I need to read and write from it directly. I cannot yeah. Okay. I mean, that part looks kind of fine, bro. That part looks kind of fine. And there's the ROM size, RAM size. Okay, so this is the right one. Yeah, I mean, I don't know what's wrong. If index less than that, I mean, I can do a return nothing here, just so it behaves as it previously did. But I mean, I don't have RAM to enable, so this shouldn't be doing anything. Okay, so if index greater than 2000 and address less than 3 Fs, bank number equals that. I mean, I did change this part here a bit, you know. Maybe I can do this and see if maybe I messed up like my logic or something. Then the 4000 like kind of the same. Value and B 11. RAM bank equals that. I don't know, it's weird. There's something weird I did that messed everything up. Which I thought it could be like this right here. Like right in here, but and this is returning. It's not writing. What I mean. I'm writing on BF. But BF is supposed to be external RAM from the cartridge. But the cartridge doesn't have it, you know? But I mean, maybe it's this part here. I mean, I wasn't doing anything here. I was just legit letting it go. So what happens if I comment that out? No. What happens if I do this? Also no. Have I touched that screwed this up? Okay, 6007 Fs. Value, banking mode equals that. Return. 4005 Fs. Memory bank dot RAM bank equals bank number. With a return. These had a return. These didn't have a return. I feel like I'm just trying to guess now. I'm just guessing what happened. But it doesn't make much sense to me. Okay, read. Read. Okay, so I get memory, get this, I get this. I have the 3 Fs. I mean, maybe I'm returning address RAM instead of address ROM. Somewhere, I don't know. But the rest is fine, so let's see what can be the issue here. Okay, so this is a ROM one. And if greater than 4000 and less than 7 Fs. I mean, yeah, I did also change this. Maybe I messed up the indexing somehow. And this is literally the only thing that I changed here. So maybe now I'm reading from the wrong place, which is causing all of this. Yes. Okay. Okay, so we found one culprit. We found one culprit. So whatever we do here doesn't work as it's supposed to work. Apparently. Okay, ROM bank is 3. Or maybe here I'm off by 1. I mean, this ROM bank shouldn't be ever 0, should it? But I guess I did change something related to that, so maybe that's what's causing the issue. Hold on.
What's going on? What's going
on?
Don't understand what's going on here.
Okay, let me see if I can find it. This area may contain any of the further 16 kilobyte banks of the ROM. If the main ROM banking register is 0, it reads the bank as if it was set to 1. Maybe here I should just... I mean, this is the old code. This is the old code. I mean, this is all the same. The only thing that changed was this ROM bank index. How's it going so far? Hello. I'm trying to implement like a dynamic way of implementing memory bank controllers. I have an issue here with this part of the code for some reason. I don't know why. Like this part of the code works if I use this, but if I comment it out, this part is wrong. And I mean the only difference is this. But I thought that the banking part, like I'm not understanding it properly or something. I don't know. Like, because they say if the banking is 0, then 03Fs and ABFs are locked to bank 0. But maybe this is not what it means, I don't know. Okay, but in any case, now I have a dynamic way of adding different multiple bank controllers, and I already added support for 2 of them, and now I wanted to add support for the third one so that we could play Pokemon. But I thought I would be done by now, and I'm not, so I don't know. But essentially for the Pokemon one, I need to implement this MBC3. Whatever that means. Whatever that means. So I'll just copy MBC1, set MBC3 here. So I'm adding a new type called MBC3. Now I need to scroll above. Well, if I try to load the Pokemon game now, it should fail, obviously. Yeah, saying, oh, we don't support type 13, which is true, because this is currently what we are trying to do. So we are trying to implement this MBC3 RAM battery. So yeah, we need to do 13, and this is gonna be MBC3 new. We passed ROM, RAM, and I don't know. I'll leave it as it is for now. Yeah, but essentially now I have this new type MBC3, where I need to essentially implement this logic here. Yeah. So when reading, if I'm reading from 0 to 3Fs, it's the regular ROM. If I'm reading from 4000 to 7Fs, I'm reading these ROM banks here, but apparently banks 24 and 60 should be supported now. I don't know why. I don't know why. And then from A0s to BFs, it selects the RAM bank or the RTC register, depending on the current selection. so I might have like an RTC register like inside. Or not, like, I don't know. I legit do not know. There are some of them that have like a timer, you know, like an MBC3 plus timer, MBC3 plus timer, plus timer plus RAM. And this is just plus RAM, so I don't know what this means. This is essentially like lots and lots of reading and trying to understand what the hell is going on and then trying to fix it. That's essentially the plan. Okay, so whenever I'm writing to here, depending on the current bank number, this memory space is used to access an 8 kilobyte external RAM bank or a single RTC register. The mapped RTC register can be written by accessing any address in that area, typically using address A0. Okay, so I'll need to figure out if I am actually like using, instead of the RAM, if I'm using like the RTC register. Yeah. But in any case, when writing from 0 to 1F, a value of OA will enable reading and writing to external RAM and to the RTC registers. A value of 0 will disable either. Okay, so here only a value of 0 will disable them. Apparently. And then from 2000 to 3Fs, this is the ROM bank number. Same as for MBC1, except that all 7 bits are written. All 7 bits of the ROM bank number are written directly to this address. Oh. Okay, so here the value is the bank number directly. So I don't need to do like these like weird shenanigan stuff. I see. Writing a value of 0. We'll select bank 1 instead. All other values, select corresponding ROM banks, okay? Can I like I don't know, ban. Okay, address 4000 to 5F. RAM bank number or RTC register select, write only. Control what is mapped. Okay, so here I'll get a value. Okay. So it is the value. Okay, so I'm gonna match the value. And if I am between 0, 0 and 0, 7, then I do something. Else, from H to C, I do something else. Else, I do nothing. Cool. Okay, so here is for the RAM bank. Okay, in here I just do this. Okay, but for 8 through C, it selects the register. So it either selects the fuck. Oh. Self RTC register equals value. Use size. RTC register 0. Okay, looks like I'll actually need to store like data here, like it timestamp? No, what's it called? Is it system time? Never remember this. Rust time. I mean, it's not really an instant span of time. No, system time. Okay, so maybe this is what I need to do. I need to store a system time. Okay, so this sets the RTC register that is selected. It's either a RAM bank or the register. Okay, so this is like actually writing the thing. I mean, but this is either RAM bank. Okay, so I guess that whenever I write to RAM this, I'll set the RTC register to 0. Yeah. Latch clock. When writing 0 and then 1 to this register, the current time becomes latched into the RTC registers. The latched data will not change until it becomes latched again by repeating the write 0, 1 procedure. I don't understand. Okay, can I do the if value equals 1? Self dot datetime equals system time now. So this essentially like updates the internal clock. Depending on the current bank number or RTC register selection, this memory space is used to access a bank or a single RTC register. The mapped register can be read or written by accessing any address in that area, typically using. Okay. So if when I do this, I need to check if I am if my RTC register is 0, then I need to read from RAM. Return address RAM. Okay, I would say this. If RTC register is 0, then I have the RAM bank enabled. So this should kind of behave the same as the other one. So it's external RAM. So the RAM base is whatever address I give it minus a 0, and then I add the RAM bank times 2000. Yes, this part here looks proper. Now else I'm gonna need to match on self RTC register. This is either gonna be 8 or 9 or A or B or C. Oh, but this is the right. Yeah, it's fine. So self dot date time. No, bro, hold on. Date time dot. Can I like set the number of seconds? Just date time set seconds. This is a timer even. I don't think I have a timer here. I don't think I am supposed to have a timer here. Am I? I don't know. Okay. I mean, let's see if this works. I'm about to end stream no matter what. So it's fine. Not implemented. Line 489. ROM size larger than this. No, I don't think I need to do anything special here. Okay, hopefully something cool is gonna happen. If not, GG. Okay, Pokemon Red version and new game and hello there, welcome to the world of Pokemon. My name is Hoke. People call me the Pokemon Prof. GG. I mean, we have more stuff than before. We weren't able to watch these previously. So whatever we did, hell yeah, it worked. This world is inhabited by creatures called Pokemon. Hell yeah. Nice. For some people, Pokemon are pets. Others use them for fights. Myself, I study Pokemon as a profession. First, what is your name? My name is going to be... Oh, I can't put numbers. I thought I could put numbers. Oh, I can select like lowercase, but not numbers. Sad. Okay. I'm gonna be do the Zor. Yeah, I mean it won't even let me write like my entire name. I'm gonna be dude. Right. So your name is Dude. Pretty cool. This is my grandson. He's been your rival since you were a baby. What is his name again? His name is Wolf. It's my #1 enemy. That's right. I remember now. His name is Wolf. Dude, your very own Pokemon legend is about to unfold. A world of dreams and adventures with Pokemon awaits. Let's go. I mean, hell yeah. I guess this literally means that now I can play like Pokemon until the end. Dude is playing the snake. Okay, it's time to go. Bloop. Can I make the text faster? I mean, I can probably save. I don't know what's gonna happen. Nothing, because I'm not saving this to a file. But I probably should, you know? Like if a cartridge has a battery, I should always like save the value of the external RAM somehow. Hello, Mom. How do I run? I can't run. Blue, 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 blue. Okay. Let's catch our first Pokemon, and that will be it. I mean, pretty cool. I'm very happy. I'm very happy. Fortunately, it wasn't that bad. I think that one thing that I could do for the community, you know, because there is stuff that I've been trying to do that is like fairly difficult to understand in terms of emulation. And one thing that I could try to do is like, for example, well, while this waits, but for example, I could try and grab all of the existing ROMs, you know, that exist or something, and kind of map them to this table, so that people could at least know, okay, if I want only games with cartridge type whatever to test, I could find this, for example, you see? Because this would have been useful, because if I want to actually implement like all of these subset of cartridge types, I will need to have like one of each at the very least, and I don't know where to find those. I'm fed up with waiting. Okay. I'm gonna grab the best Pokemon. Bloop, 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 bloop. Hurry up, old man. Hey, Gramps, what about me? Be patient, Wolf. You can have one too. That one's Squirrel. Nah. Nah. I want like the actual best Pokemon. Charmander. Yes, I want Charmander. GG, we got our first Pokemon. Do you want to give a nickname to Charmander? No. I actually don't want to. Can I exit? Select. Oh, select toggles uppercase, I see. Okay. Who's he getting? Squirrel, obviously. I'll take this one then. Dun 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 dun. That's how I imagine that would play. Okay, now we leave and he tries to fight us. Let's check out our Pokemon. Come on, I'll take you on. I love how Professor Hoke says, yeah, I just collect Pokemon and study them. And the first thing that his grandson does is like use them to fight. Wolf, send out Squirrel. Fight. Enemy squirrel used to tackle. What does growl? It increases like attack. Oh. Bloop, 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 bloop. Yeah, bro. So whenever I use growl, they use tail whip. So I guess we'll be here like a long time. Scratch. Maybe we are going to lose, you know? Oh no. Oh no. Tail whip. It feels slow though. I remember that it played like slightly faster. Can I actually lose this battle? I've never lost this battle. But I would say that they probably make it so that you never actually lose, you know? Charmander, level up. Okay. Damn, you beat me. Yeah, I mean, you kinda suck, you know? You are terrible at Pokemon. I challenge you, Pokemon Master. Okay, everyone. I'm very, very happy. Hell yeah. More confetti to celebrate. Yeah, I was kind of doubting that we'd actually be able to play Pokemon today, but we pushed through and we were successful. There's still something here that, I mean, I just put it like an implemented there for games that actually have a timer, which our game currently do not. But I mean, yeah, it's fine. I mean, it's playing Pokemon. So I guess that tomorrow the plan is that I'll probably look for the basketball game that I played when I was a child, like the first Game Boy game that I had. I'll look for that one and I'll try to play it. And I think this will be tomorrow will be like the last stream for the Game Boy emulator. Yeah. I think we are pretty much reaching the end of this. I don't know what more to work on that makes it entertaining, you know? I mean, it was cool like at the start because at the start nothing worked and things started working slowly, but now it's different. Now pretty much everything works. So what's the point of continuing, you know? I might work on it like off stream for myself, but I don't think I'll do it as a stream content because I think that lately the Game Boy streams have been very low energy from the part of the chatters, you know. But it's fine. It's fine. It's part of life. Everyone, I want to thank you for watching the stream, for keeping me company, for supporting enough with followers and subscribers. If you do not know, I have a Discord server which you can join and we can like talk offline whenever you want. And yeah, and also if you are watching and you don't follow the channel, please do. I'll appreciate it. I'm trying to get to 20 followers by the end of May. I think it's gonna be hard, but we'll see. Everyone, thank you very much. I hope to catch you again tomorrow morning. Will probably be the last stream of the Game Boy, and then on the afternoon I'll pick something else. I'll see you then. Sounds like a plan? Sounds like a plan. Okay. See you everyone. Thank you. Bye bye.